Today we're going to look at problem number 4 on day 4, week 2. Function is 4x cubed plus 2ax minus 7a, and you're dividing by x minus a, and you're getting a remainder of negative 10. So let's say I had 2x squared plus or minus x. I think I want to go minus 3 equals 0. What's a factor of that? Yeah, you're going to factor that into 2x. I think it's minus 3x plus 1. Does that work? Yeah. So I think that's right. Correct? So then what you're going to do, if you can just not talk, it'd be great. 2x minus 3, the two roots are x equal to 3/2 and x equal to negative 1. That means that if you took the coefficients of x squared, x, and the constant x to the 0, if I put a negative 1, what do you expect the remainder to be? That's what I'd expect. And let's see, wait, what did I do here? 2, negative 2 adds up to negative 3, 3, and 0. What does this mean when the remainder is 0? It divides evenly. It's a factor, right? So what if I made a mistake here and I put in instead, I put in a 1. Okay, 1 isn't going to work. 1 is going to get me what we call a remainder, and the remainder is negative 2. Okay, the neat thing about this is that if you put a 1 in for this, what do you get? Negative 2. What is negative 2? The remainder. So the factoring, this theorem, remainder theorem, simply states that if you put the root, in this case the root was 1, you're going to get the remainder. It's not a very creative name, remainder theorem. You find the remainder by sticking the value in. But I hope you're paying attention. This is super helpful. What if I put a negative 1 in, the one that I know is going to work? Now I'm going to get 2 minus a negative 1, which is 3 minus 3 is 0. There I get my remainder. So we don't have to do this whole synthetic division thing. All we need to do is put in the value. Now in this one, what's the root that we're putting in for this part A? What's the root? The root is A. You get that by going x minus a equals 0, so x is just equal to a, and a is the root. Now if I stick that in for x, f of a, I'm going to get 4a cubed plus 2a, which is a squared, minus 7a, and what will it be equal to? Negative 10. Yep. Yep. Called the remainder theorem. Stick in the root, get the remainder. They're telling you if you put in this a, you're going to get a remainder of negative 10. So now all you're going to do is you're going to have to put this in your calculator. 4a cubed plus 2a squared minus 7a plus 10 equals 0. I'd put that in my calculator, and then I would see where it hits the x-axis. Or you can set it, equal to negative 10, and then take that function, see where they cross, however you want to do it. But you're going to get a equal to what? Negative 2. Now, you could have gotten that by trial and error, but I wouldn't do that. I'd use the calculator. Then it says, show that this value of a is a unique real solution. In other words, all the other ones, how many other ones are there? 2. All the other ones are going to be unreal, man. Yeah. So, maybe, yeah. So maybe what we want to do is maybe we do want to do the synthetic division for 4a cubed 2a squared negative 7, and the last one is, yeah, 10, because I put it all in a row. And then I'm going to take out this negative 2. In other words, I'm going to drop the 4, multiply by negative 2, get negative 8. Add these up, I get negative 6. Multiply these out, I get 12. 12 minus 7 is 5. 5 times negative 2 is negative 10. What happens? Are you surprised? I'm not, because what we knew was going to happen is that this is going to be a factor, so we're going to get a remainder of 0. But the part that maybe you forgot is that these are exponents of, well, we had a here, but I'm just going to call it 4x squared minus 6x plus 5 equals 0. And I'm going to prove that the roots of these are unreal. So all I'm going to do is call this A, B, C, and check out my quadratic formula here. 6 plus or minus square root b squared minus 4ac all over 2 times 4. Now, this 4 times 4, this is 20 times 4. This is going to be 80. So 36 minus 80, what's going to happen with that? That'll be negative. So x is equal to 6 plus or minus the square root of negative 44 over 8. And this, therefore, terms are complex or imaginary terms. I'd say the factors. The roots are imaginary. Therefore, a equal to negative 2 is only real root. For this next one, it says write down the quadratic expression. Well, this, wow, how did I do that? Must have had this problem on my brain. This is going to be plus and minus. So it says write down the expression as a product of 2 linear factors. So when we get to part B, it says find the coefficient of x in the expression of 2x squared plus x minus 3 to the 8th. Now, you do not want to multiply those out. But you could do this, 2x plus 3 to the 8th and x minus 1 to the 8th. I factored this one. It's just factoring. Yeah, no, it's factoring from Algebra 1. You have 2x and x, 1 and 3. You got to get the middle term of x. 3x minus 2x will be 1x. Then what I did is I have these two. I'm taking to the 8th power. Now, it says we want the expression of which term? X, right? So with that, a way to do it is think about this one here. If we want just the x, can you see that it's going to be this 3 to the 8th times the one that has x, and this negative 1 to the 8th, and this one times x? So let's go this way. 2x plus 3 to the 8th. Now that's going to be 2x to the 8th, right? Then it's going to be 2x to the 7th times 3 to the 1st. And then it's going to be blah, 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 on and on we go. To the 8th, the coefficients are going to be 1, 8, and so on, right? And then when I do this other one, which is x minus 1 to the 8th, you're going to have a bunch of stuff. But at the end, I'm going to have negative 1 to the 8th. And before that, I'm going to have x to the 1st and negative 1 to the 7th. And what will the coefficient here be? 8. Yeah. So I don't care what else happens, but what I do care about is that this one wait a minute, did I do that backwards? This one I didn't want this part. I just wanted the 3 to the 8th, and I wanted the 2x to the 1st, and 3 to the 7th, and this is going to be 8. Yep. Okay. So then what will happen is I want this product, and I want this product, don't I? So if we took 8 times 2 times 3 to the 7th times negative 1 to the 8th x and added it to 8 times negative 1 to the 7th times 3 to the 8th times x, this should give it to me, and I'm going to need your help. Negative 1 to the 8th is a positive, right? And this is going to be 16 times 3 to the 7th. And then this is going to be a negative 1, so it'll be minus 8 times 3 to the 8th. All of this times x. Can you crank that out in your calculator because there's no other way? I agree. In the video here, I just want to mention, the question was, why don't we need the other terms? Because they're saying what term has only x to the 1st in it. The rest will have x squared, x cubed. Yeah. 1. For number 14, the volume is pi going from 0 to 10, pi r squared, so it's just x squared, I think. But that's the curve. Oh, we're rotating about the y. Okay, so here's the curve, y equal x squared. But if we're rotating around the y-axis, we probably want to say x is the square root of y, wouldn't we? So when we square square root of y, what happens? You get y. So that's why they get pi y. And then when you work this out, it's going to be pi. I think they're going from 0 to h, though, aren't they? When the glass contains water at height h, yeah. So you're going to go y squared over 2 going from 0 to h. And so you get pi y squared, or pi, I think we'd say pi h squared, pi h squared over 2. It'll probably enter later, yeah. So then it says if the water in the glass evaporates at a rate of 3 cubic centimeters per hour. When I see a cubic centimeter per hour, would you take a moment and write 3 cubic centimeters per hour? This tells me what that variable is. It's d something dt. And with the cubic centimeters, that tells you it's area, length, or volume. Volume, dv dt. Is it evaporating or is it being added to? So what can you say about this 3? It's negative. The word evaporates means it's decreasing volume. Okay? That's huge. That's huge. All right, so surface area show. Oh, we have to show that? Okay. So for part B, the key to part B is the change in volume with respect to t is equal to -3 for each centimeter squared. So what they're saying there is that for the surface area. And so we have to find that surface area. So remember what you're doing is you've got this situation, and this is at a certain height. So this x here is translated into a y value. So the x here is at a certain height, which we're calling y. Okay? So for the surface area is going to be pi r, and the radius is y squared, because this is the radius of the circle. The surface area is just a circle, pi r squared. Well, when we go back to y, remember that the volume is equal to pi h squared over 2. Okay? So if we take 2v over pi, we're going to get h squared. So if we h is just going to be, well, that'll be equal to h squared. Now y is the height, so this is h squared. Oh, I see what the error was. This length here is x, and this is my height. So the area is pi x squared. So what you want to do is x is equal to the square root of y, okay? And y is your height, square root of the height. So that's why when we're solving for h, we want this solve for square root of h squared. So h, square root of 2v over pi, okay? So then when you put that in to this equation, dv dt is equal to negative 3 pi, and then you're going to have h, which is the square root of 2v over pi. And dv dt, negative 3 pi times, well, what I'll do is I'll take that negative 3 square root of 2v. Pi over the square root of pi is still the square root of pi. So there's your formula.